Hello friends, welcome to my second video lecture based on laser. Laser itself stands for light amplification by stimulated emission of radiation. Friends, at the last video lecture I have already discussed about some basic properties of laser. That is, laser is a highly directional and laser is a coherent. Why laser is a coherent and why laser is a highly directional? Because the name itself indicating it is the amplification of light and which must be stimulated emission of radiation. So friend, if there is a no coherent, that means laser is not a directional. Coherents make itself a directional. Suppose we have a random direction of light like this. This each and every direction of light have individual phases. So this light could not be added at particular directional. If we added this, the first, second, third and fourth direction of light in some particular unidirectional, then light with its constant phase difference, it's make a highly directional light. Okay, so this is the very important parts of laser. So today I am going to discuss about the types of radiation. There must be in laser absorptions radiation and emissions of radiation. So these are the two types of radiation that must happen in laser: absorption of radiation and emission of radiation. Friends, suppose I have a material, that material having the large number of atom. Suppose that material having a large number of atom and infinite number of energy state. So you may consider about that infinite number of energy state, you may consider two energy state. Suppose the first energy state is E1 and the second energy state which is a E2. Keep it in mind, the energy of E1 is less than the energy of E2. Suppose this material having n1 number of atom here, and this excited state having initially no atom. So this atom here, it is a stable atom. So if I am externally provide some energy in the form of photons or any kind of energy, so in my case I am discussing about only in the form of energy in the form of photons. So this atom get excited and release its electron, and that electron it jumps to a higher energy state here. So it is not a stable state, it is just the electron which is excited from this atom. That means this is the excited atom and this must be unstable. So this time period of instability is very less. So that atom will try to stable and it will come back to its original position, because when it is jump from this position to this position, it's make here a vacancy. Okay, so this is the part of absorptions of radiation. First, the atom which is stable in the ground state, that state must be energy E1, and that energy which is absorbed from the externally applied energy, then the electron can jump to the higher energy state. That means this atom is absorbing some energy. So that is why this type of state is known as absorption of radiation. Friend, when this atom will jump from energy state E1 to E2, when it will have the sufficient energy, that means the energy unit of, suppose if you consider the energy unit of state E2 is 5 and energy unit of state E1 is 2, that means this will be energy state, this much energy required to jump from the energy state E1 is 5 minus 2, that means 3 energy unit they need. That means this energy must be h nu, that is which is equal to E2 minus E1. So in my case, in our case, we need 3 energy unit at least to jump from the state E1 to jump from the state E2. Now let us discuss about the emission of radiation. This emission of radiation is two type of emission. One is spontaneous emission and another one is stimulated emission. So we'll discuss one by one. So spontaneous emission and stimulated emission. So let us see one by one what is spontaneous emission and what is stimulated emission. For laser we need stimulated emission, but here I am discussing emission of radiation by its two category. One is spontaneous emission and second is stimulated emission. So first it is happening spontaneous emission, because friend, here we already learn about absorption of radiation. What happen when the atom get excited? Atom absorb the energy from the external source, and this atom will jump from here to here. Then it's look like this. This atom can jump and it's create a vacancy here, and this atom jump to this position. So now for spontaneous emission, this is the initial position having the energy state E2, and this is the energy state E1. So what happened? The time period of the spontaneous emission is very small, that is 10 to the power minus 8 second. So after the 10 to the power minus 8 second, this atom, excited atom, will be try to come back to its stable state. So this atom is try to come back its stable state like this, here to here. So when this atom come from the energy state E2 to energy state E1, it releases some energy in the form of photons h nu. So this kind of radiation, which is called as spontaneous emission. First we learn absorption, now this is spontaneous. Spontaneous emission is the just after the second part of absorption of radiation, because first atom get absorb energy and it jumps to the second energy, higher energy state, and after atom can stay some time, the time is very small, that is 10 to the power minus 8 second, and now this atom is decaying or come back to its original position by releasing some amount of energy. That energy E is equal to h nu. So this much of energy released by the spontaneous emission. But we need for laser, the light must be stimulated. We does not need the spontaneous emission, we need the stimulated emission. So when this atom release the energy in the form of photon h nu, so this energy, it is in any direction, maybe this direction, maybe this direction. So that means the direction is random, or you can say any direction. But what we need for laser, laser light must be coherent. So if there is no coherence is maintained, that means it is a random. If it is a random, that means there is no laser action happening. Now I am talking about the last part of this video lecture, that is stimulated emission. So what happened, friend, for the stimulated emission? So here what happened, this is already atom can absorb the energy and the excited, and it will come to the higher energy state. So before the time of 10 to the power minus 8 second, here before completing the time of 10 to the power minus 8 second, here already passes one more external energy in the form of photon h nu. that energy is equal to h nu. So what happened here? Now there is a no extra extra atom is present. So where to go this energy? This energy just come to this atom, and it will get again excited, but there is a no higher energy state is present, because that unstable atom must go to its vacant position. Here is the vacancy. If there is a vacancy present, then there should be a chance to atom go to the higher energy state, because there is a no higher energy state now present, because the vacancy or deficiency space or vacancy of this atom is present at the lower state. So by heating or striking the new energy in the form of h nu before the time of 10 to the power minus 8 second, so what happened here? This atom, unstable atom, is try to come back to its original position. That position I have mentioned here. So it will come back to its original position now. So when it is come back to its original position, so because of that energy difference, they release energy h nu, which already gained by atom earlier when the time of absorption. That energy is h nu 1, and before the time period completion of 10 to the power minus 8 second, this atom again absorbs some energy, that energy in the form of again h nu. So because of that, this atom forcefully come back to its original position. So due to that, they also release the energy which gain later, that is in the form of photon, that is h nu. So here I am applying the simply energy, only one energy, and you get the radiation 2 energy, that is energy E1, and this is energy E2. So we'll get the 2 energy. So in this manner it will get multiple, and the incident of radiation and the emission of radiation both have the same direction, and the phase difference between these two energy form is constant as the time changes. So because of that, it is a coherent in nature. If it is a coherent, that means it is highly directional. So what we need for laser? We need for laser, it is a highly directional. So such that these two electromagnetic waves or these two waves, they can multiple and they produce a high intensity waves like this. This is the two waves. When mixed, they produce a high intensity. So that is why intensity of laser is higher. So the basic difference between the spontaneous and stimulated emission is, spontaneous, it is automatically happening, because after the time of 10 to the power minus 8 second, this atom is automatically come back to its original position by releasing some some energy h nu. But in spontaneous emission, the atom is forcefully, or unstable atom or excited atom is forcefully come back to its original position. So this is the basic difference between spontaneous emission and stimulated emission. So I hope student, you understand now what is absorption, what is spontaneous, and what is stimulated. So I will try to summarize these three. Radiation, absorption means now atom is absorbed and excited. Spontaneous means after 10 to the power minus 8 second, it is come back to its original position. And stimulated means it is forcefully come back to its original position, because we are already before computation of time 10 to the power minus 8 second, we already provide some energy h nu. So it will come back to its position forcefully, and it is a coherent and it is a incoherent. Spontaneous, it is a incoherent because the direction of emission of radiation is random or any direction, but here the direction of radiation is same as the direction of incident wave. So that is why this is a highly directional and which is a coherent. So for laser we know light amplification by stimulated emission of radiation. So we need here stimulated. So this is the stimulated action which must for laser. Thank you very much. We'll continue this laser in the next lecture. Thank you.